So yesterday we developed that bad boy. Bad boy. What you gonna do? Whoa! What you gonna do, Frank? When they come? Bad boys, bad boys. It's the roids talking, right, Frank? Yeah. So roid rage. Coming up, you will have a unit circle memory quiz. Not a unit circle developmental quiz, a unit circle memory quiz. Okay? And yesterday I said, well, we're probably going to do that on Friday. Well, we've changed our minds. We being me. Or my mind was changed for me. We're probably going to do that on Monday, Tuesday, whichever day you have the form on. Okay? So that doesn't mean that you shouldn't start memorizing it, though, because you should memorize it. And remember what I told you yesterday in class. If you had me in class yesterday, really you only got to memorize 2 points, right? Memorize the 30 degree or the pi over 6 point and the pi over 4 point. Okay? So because the pi over 4 will get you all of the fourths, and the pi over 6 will get you all of the over 6th, and then if you flip-flop the x and the y, it'll get you the over 3s. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Okay? So just know that. And then the other 4 are just ta-da. With me? Now, on top of all of those points, the unit circle memory quiz, remember, it's a memory quiz, it's not just a let's develop the unit circle quiz, okay, is also going to ask you, what is the cosine of t? What is the cosine of t? Say it loud. X. It's also going to ask you, what is the sine of t? Y. It's also going to ask you, what is the tangent? I don't like my tangent. It's also going to ask you, what is the tangent of t? Y over x. Then on top of those 3, it's going to ask you for their inverse pairs. So what is the inverse pair that goes with cosine? Secant. What's the inverse pair that goes with sine? Cosecant. Hopefully that wasn't a cosine that you said over there, Mark. That's right. Okay. Right rage. And what's the one that goes with tangent? Cotangent. Okay. So all that stuff's going to be Monday, Tuesday, whatever day you have your form on. Okay. So let's dive head first in. I want to use your unit circle. So you should always have your unit circle ready to go at a moment's notice. Like this is a great spot for your unit circle inside your protective binding of the front cover of your binder. That's a great spot. First page in your 3-ring binder when you open it up, so that you can use it whenever we need it. Okay? And we're going to use them a lot, okay, from now on. So how we're going to use it today is, I'm going to give you the question, what is the value of the sine of pi over 6? And you're going to say to yourself, and then you're going to say, oh wait, ding, 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 I've got a unit circle. Okay? And so what you're going to do is you're going to go to pi over 6. And pi over 6 is up here. Okay? So pi over 6 is right here. I should go on here so that the people on the line, if you will. So you're going to go over here to pi over 6. And you're going to say to yourself, self, the sine of pi over 6 is the x value or the y value? The y value says so right down here. So then I'm going to look for the y value in the point, and that's going to be positive 1/2. So the sine of pi over 6 is 1/2. Cosine of 4 pi over 3. Can anybody tell me what the cosine of 4 pi over 3 is? Do we agree with negative 1/2? I would concur that the cosine is negative 1/2. The tangent at 3 pi over 2. Tangent, remember, is y over x. So the y value at 3 pi over 2 is negative 1. The x value at 3 pi over 2 is 0. So what does that equal? Undefined. Very good use of the word undefined. Okay? When we're dividing by the 0, we call that undefined. Okay? What I would like you to do now is I would like you to find me those 6. Utilizing your unit circle.
Boy, I hope you paused it and are doing these instead of just waiting for me to do them, because that would be really helpful for you.
Oops, I did it again. You Britney Spirited?
Yeah, I Britney Spirited.
Tangent of 5 pi over 6. So I go over to 5 pi over 6, and I say to myself, self, the tangent of 5 pi over 6 is y over x, and that's going to be 1/2 over negative square root 3 over 2. And then I say I got a fraction and a fraction and a fraction. But, hey, do I like fractions and fractions and fractions? I don't like fractions and fractions. Now we put a third layer on it. Not good. So we got to go take a little trip back to 4th grade. We talked about 4th grade yesterday. Mrs. Hoyman was my teacher. Yep. And we flip the second one. And then we would say to ourselves, self, well, those 2's, I got a 2 on top and I got a 2 on the bottom, and those 2 are going to cancel each other out, and that's going to leave me with negative 1 over the square root of 3. And because we're dealing with the unit circle, we're cool with that. If we, yes ma'am,
Could you just,
rationalize it.
well, if you just put them like next to each other and do 2 divided by 2, 1 divided by negative square root 3, it's negative square root 3, then just flip it.
She said-
So then it's, oh, dang it. Oh, no. And then it'd just be negative 1 over square root.
She's talking about canceling the 2's out. So like if
Yeah.
there's a 2 on top and 2 on the bottom, you just kind of like cancel both out.
Kind of like what I did.
Yeah, that's the complicated.
How is yours less complicated than mine? I literally drew 2 slashes and it's gone. Oh, but up top there?
Yeah.
Oh, no, you gotta flip it. You gotta flip it. Because otherwise you get confused, and then I don't want you to be confused. You know what I mean? Yeah. The flip is the most important part. Okay. Yeah.
You can just leave it like that.
We can leave it like that. Or we could rationalize that denominator, and we could say that this is negative square root of 3 over 3. Okay? Cotangent of pi over 4. Well, the cotangent of pi over 4 is x over y, so that's going to be the square root of 2 divided by 2 divided by the square root of 2 divided by 2. Again, fraction in a fraction in a fraction. However, this one is much easier because both top and bottom are the same. So that just gives me 1. Cosine of 7 pi over 6. Cosine is x's, so this would be negative square root of 3 over 2. Concur? Love it so far. Uh-oh, I forgot. I wanted to do El Shadow. And then bring it down. And then bring it down. Whoa, not that bring it down. Secant at 2 pi over 3. Secant is 1 over the cosine, so that's 1 over x. 2 pi over 3 has an x value of negative 1/2. 1 divided by negative 1/2 is negative 2. Cosecant, pi over 2. Cosecant is 1 over the sine value, which is 1 over y, which is 1 over 1, which is 1. Sine, 11 pi over 6 is the y value. I get negative 1/2. Agree? Utilizing the unit circle. Good times. Very good times. Just when you think you have all the answers, what do? I go and I change the question. What is the cosecant of negative 3 pi over 4? Let's go back here. Let's get rid of that. If I go that way on the unit circle, that's my positive direction, correct? We call that counterclockwise, correct? Okay. If I go the other way, if I go clockwise from 0, then that becomes the negative direction. So if I need to go negative 3 pi over 4, I'm going to utilize my fourths. Here is negative 1 pi over 4. Here is negative 2 pi over 4. Here is negative 3 pi over 4. Okay. So I'm down here at a positive angle of 5 pi over 4, but that's also negative 3 pi over 4. The reason I'm bringing this up is because if you choose to do that extra supplemental worksheet tonight, there are some negative angles on there. And so we have to talk about that faster than what we thought of. Okay? But we'll go over this more later this week. Okay? So this then becomes 1 over, we're talking cosecant, that's sine. So the sine value there is negative root 2 over 2. So if I go 1 times negative 2 over the square root of 2, well then that's going to be negative 2 over the square root of 2, or simply if I multiply both top and bottom by the square root of 2, I get negative 2 square roots of 2 over 2, which is just negative square root of 2. Okay? This concludes our self notes. Now we will be moving to the obviosities packet. Once again, as I said before, 2/3 of the way through class, we would be moving to the obviosities packet. Now, you may be saying to yourself, what's obviosities? Well, obviosities are what I like to call obvious observations. Okay? Or some people might say it's the plural of obvious. Obviosities. Okay? Things that you should know that you probably don't know, but you probably do know and just haven't really thought of yet. Okay? Okay? For instance, the first one is, let's talk domain and range of our unit circle. Okay? So our unit circle goes to the right all the way out to the point 0. Oops, tap the brakes. Goes to the right all the way out to the point 1, 0. It goes all the way to the left to the point negative 1, 0. All the way up to 0, 1, and all the way down to 0, negative 1. Right? From your extensive knowledge in the fields of domain and range, my question to you is, what's the domain?
Negative 1 to 1.
Okay. And is that horizontal or is that vertical?
Horizontal.
Because domain is x's? Yep. Remember that domain is x values. So the domain here would be from negative 1. Now, are you including negative 1 and positive 1? Yep, I would also. So that would be negative 1 is less than or equal to x is less than or equal to positive 1 if I wrote it in inequality form. If I wrote it in interval form, I would have a bracket, negative 1 to positive 1, and yet another bracket, because we are including those values. I would agree, because left and right, so I'm looking at the circle, it goes all the way from negative 1. It doesn't stop until it gets to positive 1. There's no breaks, there's no gaps, there's no stoppages in it. So if domain is x values, what's range then? Y values. Okay. And what would the range be of the unit circle? What would the range of the unit circle be? Except the only thing that's different is, instead of x, it's y. Yep. Yep. So the domain here, the range would be from negative 1 less than or equal to y is less than or equal to positive 1, or if I wrote it in interval notation, it would be Again, this is stuff that you know, and clearly you know it because you're participating and answering these questions without much prompting. Okay? You know this stuff. You probably just never thought, well, yeah, well, duh, the range of this is the range of that, and the domain of that, and all this good stuff. Okay? So we're good to go there. All right. Next one. Uh-oh. I forgot to put the box on there. Oh, well. Okay. What is the equation of the unit circle? What is the equation from yesterday? What's the equation of the unit circle, Lisa?
Isn't it x squared plus y squared plus
Love it. Couldn't have said it better myself. But side note, we also just learned that the cosine of t is equal to x. Right? We learned that yesterday. And the sine of t is equal to y. Right? So we could say here, right? Which we would write that, or we should write that, I should say, as what I like to call the hammer Anybody know why we call it the hammer? What? What'd you say? Because it smashes things? Nope. Anybody know why? No. Doesn't really look like a hammer. Anybody? What's the one tool you gotta have in your toolbox? No, you gotta have a hammer. You gotta have a hammer in your toolbox. Okay? So it's the one tool that we need. Gotta have a hammer. Okay? That's one way. Another way? Huh? It's the tool that builds America. The hammer. Okay? This build trait. So, if the cosine of t is equal to 1/2, find the sine of t. Well, if I'm utilizing the hammer, jump up a little bit, that way the people in the back can see. If I'm utilizing the hammer, then the cosine squared of t plus the sine squared of t has to equal 1. Well, if cosine of t is 1/2, then this is going to be 1/2 quantity squared plus sine squared of t, and that's going to equal 1. Well, what's 1/2 squared? 1/4. How do I want to go about solving that? No, even easier. Subtract 1/4 from both sides. Okay? So then that gives me sine squared of t equals 3/4. I want to solve for sine. I want sine. I don't want sine squared. Square root both sides. Left side, what do we get? Sine of t. I'm solving, correct? And I took a square root. What does that mean? Plus minus. What is the square root of 3/4? Frank, you don't need a calculator. Square root of a fraction, what do? Square root of a fraction, what do you do? Okay, so square root at the top, square root at the bottom, right? So top is square root of 3, right? Can I simplify the square root of 3? No, so that's going to stay the square root of 3. Bottom is square root of 4, which is just 2. My question to you is, do I have a cosine value of 1/2 somewhere on my unit circle? Yes? If I go to where I have a cosine value equal to 1/2, we'll go in purple, that would be like right here. Right? Cosine is equal to 1/2. Sine, my y, or my sine value, is equal to square root of 3/2. Where else is cosine equal to 1/2? Where? 5π/3. If I look at 5π/3, cosine is equal to 1/2. Sine is equal to negative root 3/2. Okay? So we're going to get two values, because if I set the value on the unit circle, either left or right, top or bottom, there's going to be two values for me. Okay? What I would like you to do now is I would like you to find me what cosine is if sine is equal to 1/4. I have 4 minutes left. Minute left. Mark, what do you got for an answer?
The square root of 15/4
That's only half the answer.
equals.
No, that's only half the answer. What?
Equals cosine of t.
Still only half the answer. Agree so far?
Yes.
Hammer time. All right. So cosine squared plus 1/4 squared is equal to 1. So that's cosine squared of t plus 1/16 equals 1. Good so far? So that's cosine squared of t is 15/16. Square root both sides. Right? Left side becomes cosine of t, which is what I'm looking for. Right side becomes plus or minus the square root of 15 over. What do you mean it's not worth half the problem? You only gave half the answer.
That is true, Mark. Shut up, Frank.
How many answers do I have?
You have 2.
I have 2. How many answers did Mark give?
He gave you 1.
That's only half in my book. You want to justify it even more?
1.5.
Oh, so you gave me 3 answers to my 2.
Yes.
Oh! Okay. And trust me, because remember, you got to get one above and one below, or one left and one right in this case. Okay, so you always got to have two. Always got to have two. Okay? Great spot to stop. Thanks for playing along.